Hello everyone. Last time we have done the theorem that is the Cauchy's weak theorem and then Cauchy's Gauss theorem. Now here are some examples that we have to do. The first one is evaluate the integration over C 1 by z minus z naught dz along a simple closed contour C having the point z naught as an interior point. Let's solve this example. We are constructing a circle that is z minus z naught mod equal to r. That is, your circle is like this. Suppose this is your x-axis, this is your y-axis. Now it is given that z naught is a point that is an interior point in the simple closed contour C. So if suppose this is any simple closed contour C it is given, since the domain should be on the left hand side, the arrow should be like this. And let this is the point z naught, that is the interior point. I am constructing a circle, that is it is contained in this circle, that is z minus z naught. And here suppose let this be your C1. Okay, since the domain should be on the left hand side, it is not on the left side but it is on the right side. So I have to take this contour C1 as the -1. This is your positive and this is because the direction is reversed now. So this is taken to be as negative C1. So let's start with the solution. I have constructed a circle. Construct the circle z minus z naught is equal to r, interior to the contour C for some positive r. Since the function is analytic in this multiply connected region between this C and C1, the function is analytic. And one thing more, function is not analytic at the point z equal to z naught. If the denominator is 0, then the function is not defined. So the function is not analytic at the point z equal to z naught. Alright. So since the function is analytic, f of z is equal to 1 over z minus z naught is analytic in multiply connected region between C and z minus z naught is equal to r. That is this circle. Here the function is analytic. So can I use the Cauchy's theorem? So by Cauchy's theorem, we know that if the function is analytic in the closed contour C in the domain D, then the function over that closed contour is 0. So by Cauchy's theorem, our function that is C plus C1 over this contour, the function is 0. Okay, so this implies if I take them separately, this is first C z minus z naught plus then I am taking over C1 1 over z minus z naught dz. This is equal to 0. Okay, next I take this second integral to the right hand side. So this is equal to 1 over z minus z naught dz is equal to minus of over C1 z minus z naught dz, which is further equal to, now this is because since the integral having the minus sign, this can be written as minus of C1 1 over Z minus Z0. Now I think it is clear to you. This implies 1 over Z minus Z0 dz now is equal to, now along this C1 contour, since it is a circle, so I am taking the limits, that is from 0 to 2 pi. I am taking these limits now, and it is parameterized. This dz can be written as z dash t dz over, this is zt minus z0 t. Sorry, it is dt, not dz. Sorry. Okay. So I am parameterizing this, and this zt minus z0 t, this is equal to r e the power iota t in the polar form, where the limits for t is from 0 to 2 pi. So this is equal to 0 to 2 pi. What is derivative for z dash t? You take this z0 t on the other side. The derivative is r e the power iota t into iota. Okay. So it is a point. It is arbitrary, but this is a point. So derivative for this is 0. So this is r e the power iota t dt, which is further equal to 0 to 2 pi iota dt, that is equal to 2 pi iota. Now whenever the point is inside the circle, whenever you are having the point inside the closed contour, then integral over the region over the contour is 2 pi iota. Otherwise that integral is 0. If z0 is not the insider point, if it is not the interior point, then this integral is 0. But if it is inside the circle, then integral is 2 pi iota. But if z0 is somewhere here or here or here or outside the circle, the given circle, then integral is taken to be 0. So there is a remark, that is integral over c 1 over z minus z0 dz is 2 pi iota along a simple closed contour c having z0 as an interior point. Interior point means that point should lie in this given circle. Otherwise, this integral is 0. Okay, let's do some more example that will be more clear to you. The first example is evaluate integral over c 1 by 4z square minus 9 dz, where the circle is given to be mod z is equal to 1. Now here it is given that this circle is mod z, that means it is a unit circle. If the point lies inside this circle, then integral is 2 pi iota, otherwise this integral is 0. Let's check. Let's see whether the point z0 lies inside or not. So let f of z is equal to, it is given 4z square minus 9. This is written as 1 by 4. This is z square minus 9 by 4. I am taking the 4 outside like this, which is equal to, using the formula a square minus b square, it is factorized in 3 by z minus 3 by 2 and z plus 3 by 2. Okay, now what are the given points now? The points are 3 by 2 and minus 3 by 2. So I should write that f of z is analytic everywhere except z equal to plus minus 3 by 2. So it is analytic everywhere except these 2 points. because if z is 3 by 2 or minus 3 by 2, this function is not defined, then denominator should not be 0. So fz is analytic everywhere except z equal to plus minus 3 by 2. Now, are these points lie inside this circle? 3 by 2, it is I think 1 point something like this. 1.5 other like this. So this is a unit circle. So this point lies outside this circle. And minus 3 by 2 lies on this side of the circle, outside the circle. So both the points lies outside the circle. So I should write, but the points z equal to plus minus 3 by 2 lies outside the circle. So this circle, unit circle. Hence, by Cauchy's theorem, integral over c f of z dz is 0. This integral is 0 as c is a closed contour. This is what the Cauchy's theorem says. And also points are also not lie inside the circle. Fz is analytic inside and on the circle also. Okay, except these points. So Fz is analytic inside this also, because it is not analytic at the point 3 by 2 and minus 3 by 2. Otherwise, it is analytic everywhere except these 2 points. So function is analytic inside the circle. It is a closed contour. By Cauchy's theorem, this integral over fz dz is 0. This comes out to be 0. Okay, that is integral over c 1 over 4 z square minus 9 is 0. If any of the point lies inside it, then integral is not 0. Then that integral should be 2 pi iota over the remark if you see. Next, because Cauchy's weak theorem के लिए हमें पूरी जगह फंक्शन एनालिटिक चाहिए. एक भी पॉइंट अंदर आ गया वहाँ पर तो फंक्शन, सपोज आपका पॉइंट यहाँ पर है 0.5 आई थिंक. लेट्स टेक दिस पॉइंट. सपोज आपका पॉइंट इनसाइड है यहाँ पर, तो इस केस में आपका जो फंक्शन है अंदर सारी जगह एनालिटिक है एक्सेप्ट दिस पॉइंट. तो एक ऐसा पॉइंट आ गया, एक ऐसा पॉइंट है जहाँ पर फंक्शन एनालिटिक नहीं है. और अगर फंक्शन अंदर एनालिटिक हल्का सा भी नहीं है तो आपकी कॉचीज़ वीक थ्योरम यूज़ ही नहीं होगी और उसका आंसर 0 नहीं आएगा. कॉचीज़ वीक थ्योरम के हिसाब से ये इंटीग्रल 0 तभी है अगर हमारा फंक्शन सारा का सारा अंदर एनालिटिक हो. बट इस पॉइंट पे अगर कोई पॉइंट अंदर लाई करेगा तो उस पॉइंट पे वो एनालिटिक नहीं होगा, बिकॉज वहाँ पर फंक्शन ही डिफाइंड नहीं होगा. तो उस केस में वो इंटीग्रल 0 नहीं होगा. दैट इंटीग्रल इज 2 पाई आयोटा. It will be more clearer to you by another example. Evaluate this integral over circle mod z is equal to 0.5. Now here the circle is not unit circle but the half of that. Let's check. Let's find out these points. You can see it is already factorized. We have the points 1, 2. 2 points are there. And 1 and 2 points are not lying inside this circle. These points lie outside this circle. So here also integral is fz is analytic everywhere except 1 and 2. और 1 and 2 तो हमें अंदर है भी नहीं है points. fz पूरा का पूरा अंदर एनालिटिक है. दैट मीन्स बाय कॉचीज़ वीक थ्योरम fz इज एनालिटिक इनसाइड द क्लोज्ड कंटूर c. सो बाय कॉचीज़ वीक थ्योरम दिस इंटीग्रल fz dz इज 0. ये तो देख कर ही आपको पता चल गया इसका आंसर. ठीक है. सो आई एम राइटिंग दिस सॉल्यूशन. Suppose your fz is given sine pi z square plus cos pi z square over z minus 1 square z minus 2. Now here fz is analytic everywhere except z equal to 1 and z equal to 2. But these points lies outside the given circle I'm giving the notation like this for the circle. So by Cauchy's theorem, integral over c f of z dz is 0 as c is the closed contour. This is very important. Next, evaluate this integral over c and function is given to be the imaginary part of z dz, where c is unit circle described in anti-clockwise direction. Now here let c is mod of z equal to 1. I am taking this circle to be a unit circle because it is given the circle is unit. So mod z is equal to 1. Then we know that z in polar form it is e the power iota theta. R is 1 because it is given that mod z is equal to r. R is 1, so r is 1 here. This is using the Euler's formula cos of theta plus iota sine of theta. Now what is z? Z is x plus iota y. This is equal to cos of theta plus iota sine of theta. What is the imaginary part now? It is y is equal to sine of theta. And what is dz from here? Dz is equal to, what is dz? Cos of theta ka derivative, it is minus sine of theta plus it is iota cos of theta d theta. Okay, this can be written as iota cos of theta minus sine theta. Interchanging the terms only I had. So now the given integral imaginary part of z dz is equal to integral over c. What is the imaginary part of z? Imaginary part of z is y. So this is y dz. This is equal to, now since I have taken z to be in the polar form, here the limits are theta is from 0 to 2 pi. So where theta is from 0 to 2 pi. What is y? This is sine of theta. And what is dz? It is iota cos of theta minus sine of theta d theta. So this is equal to sine iota sine theta cos theta minus sine square theta. So I am separating this integral. This is sine of theta cos of theta d theta minus 0 to 2 pi. This is sine square theta d theta. Now whenever you are having a function as, first there is a remark for you for solving this. You have also studied in the earlier classes, that is integral from 0 to 2a f of x dx. This is 0 if f of this 2a minus x is equal to fx minus of fx, and this integral is 2 times 0 to a f of x dx if f of 2a minus x is equal to f of x. So if you take, now this is 0 to 2 pi, take sine of 2 pi minus theta, sine of, instead of theta write sine of 2 pi minus 0. So this is sine of 2 pi and this is cos of 2 pi minus 0, this is cos of 2 pi. So this is overall, it is equal to minus of f of x. If you solve this, you will be having 0, this integral to be as 0 if you solve this like. So this is equal to, the above integral is 0, this is iota into 0 minus 4 times 0 to 2 pi by 2 sine squared theta d theta. Why I have written 4 times 0 to pi 2? Because 0 to 2 pi can be written as 0 to pi by 2 twice, then again twice. So this is 4 times 0 to pi by 2 sine square theta d theta. You use these two properties and you will get the answer. This is equal to minus 4 1 by 2 into pi by 2, which is further equal to minus pi. Thanks for watching this video.